And for our second example, we have, according to the Centers for Disease Control and Prevention, that's a U.S. organization, the CDC, 68% of high school students have never smoked a cigarette. For a stats project, Anita surveys a simple random sample of 150 students from her school. This is not ASM. This is a much larger high school, let's assume. She gets responses from all 150 students, and 90 say they've never smoked a cigarette. Is there convincing evidence that the CDC's claim does not hold true at Anita's school? So we want to know, first of all, this is a little bit different. It said, is there convincing evidence that the CDC's claim does not hold true? We actually aren't testing. We don't have any indication if it's greater than or less than 68% at Anita's school. We're just looking to see if it's different than 68%. And that's going to be important when we look at our hypotheses. So let's start with P, the parameter. That's the true proportion of students at Anita school. The true proportion of students at Anita school who would say they've never smoked a cigarette. That's important. It says who would say they have never smoked a student, or let's just say who have never smoked a cigarette. All right. So H is our hypotheses. Our null hypothesis is going to be that the true proportion is what the CDC states. It is 0.68. The alternative is that it's different. We want to know, do we have evidence that it's not 0.68? And we don't have evidence of greater than or less than. That's not what we're testing here. We just want to know, is Anita school different than what the CDC says? So we're just going to use a not equal to here. Next, we can check our assumptions and conditions. Let's start with random. It did state in the problem, if you look back up, it does state that she surveys, I think, a simple random sample of 150 students. We can abbreviate simple random sample of 150 students. So that meets our random condition. The 10% condition is that there are at least, so we can assume that there are at least 10 times 150, which is 1,500 students at Anita school. And let's hope that Anita knew how many that she could, how large her sample size could be. So we hope her school is at least 150 students, and then large counts. Large counts. We're going to take P or N times P naught. So 150 is N times P naught, which is 0.68. And that gives us, I believe, 80. You can check 102. It's 102, which is greater than or equal to 10. And 150 times 1 minus 0.68, which should be 48, which is greater than or equal to 10. So we've met two of the conditions, and that we're fairly safe to assume that her school is at least 1,500 students. PHAN, so N, name the test. This is called a one sample z-test. For P, the population proportion. T is calculate the test statistic. So we're going to use the calculator for that. Let's just see how many said that at her school. 90 out of 100 said they have never smoked, or out of 150. So we had 90 out of 150 we're going to use in the z-test. Number 7, one proportion z-test. Number 5. P naught is 0.68. She had 90 people out of 150 say that they've never smoked a cigarette. And we're going to keep not equal to here. Again, we're just looking for, is there a difference at her school? Not greater than or less than, just is there a difference? And what we found, it does give us the p hat is 0.6. We have the z and the p value. So let's go ahead and finish. Here we go. We found the test statistic z is, I had it written down on my paper too, negative 2.10. I think it's always good to see what the p hat is. So it does look like p hat, her population, her sample proportion was 0.6, which is less than what the CDC says. So we can see it is already different. But since this is a not equal to test, this is maybe the first time we've seen this, I'm not sure. Since it's a not equal to test, the p-value is actually, so z is negative 2.10, but you actually have to use negative 2.10 and 2.10. It's called a two-tailed test for a not equal to question. Now the z will only give you either the positive or the negative. Here it gave us the negative. We also need to use the positive. And the p-value is the sum of both of those areas under the curve. So the p-value is the sum of both of those areas, which for us, the p-value is, and it does tell you on your calculator screen, 0.0357. And so now we can make a decision. Our significance level was 0.05. So since the p-value is equal to 0.0357, which is great, or no, it's not greater than, it's less than 0.05. P is low, what do we do? 0.05, which is our alpha. We reject H naught. If P is low, reject H naught. And so now we can state a conclusion. We rejected the null hypothesis. We have evidence that the alternative is true. So that means we have convincing evidence that the proportion of all students at Anita's high school not just the sample, but we use the sample to convince us that the proportion of students, all students at Anita's high school, I'm just going to abbreviate high school, who've never smoked a cigarette is not 0.68. Is not 0.68 as the CDC states. That's what the CDC said. So we have evidence that her school is not the same as what the CDC states.